Hey guys, so let's see, we'll try this screencast-o-matic thing again. Okay, this is for significance testing. So as I said in the lesson, it is easy to say, well, yeah, I really think that men um, are more sexist about women than women are about women. I don't know, that was a weird example, but if you want to say that, look, I think that there's a significant, or that, look, there's a significant difference between these two groups. Well, somebody might say, well, prove it. Like, how is it actually significant? Why is this a significant difference? And so that is when you can do the chi-squared test using what's called a p-value, all right? And so to do that, the first check is to make sure that your variables, both of the variables that you're checking, again, it's a bivariate test. So you're looking at two things, two different variables. And so I want to make sure that both of them are bivariate. So here, my question in this case was, I wonder if there's a significant differences between the way men feel and the way women feel about this variable, do men make better political leaders? So there's my gender, and here is my variable, do men make better political leaders? So the first is to check to make sure that they are both bivariate. So, oops, not age, gender. Okay, so let me quickly check gender. I'm going to go to Analyze, Descriptive, Frequencies, and I'm going to do again, it's a univariate frequency analysis on gender. Click that over, I click OK, and sure enough, gender. Yep, I've got 1,448 people who did this study. 52% of them are women and 48% of them are men. And I didn't have any third genders in this study, so yes, it looks like only men and women did it, at least for these countries. Okay, so then I have this other question, do men make better political leaders? So let me do a quick frequency analysis for that. Analyze, descriptive, and then frequencies. Get rid of that. Do men make better political leaders? I'm going to click that over, click OK, and here is what my output looks like. Okay, so it's good that we have this. So in a way, so 230 people were not asked this question. I'll just tell you guys, I went and dug, and it turns out the entire country of Denmark was not asked this particular question. Do men make better political leaders? I don't know why. Maybe they would have laughed at it. But for whatever reason, the surveyors didn't ask this question in Denmark. Lots of people said, I don't know. So that's 145. So 230 plus 5 plus 145 equals 380. Okay, but what I'm really interested in is there a significant difference between men and women in this, whether they agree or disagree with this question? And as you can see, it's not bivariate. It's not a dichotomous variable. In fact, there's 4 possible answers. Agree strongly, agree, disagree, or strongly agree. So in this case, to make this work in a chi-squared, I'm going to separate out the people who agree or strongly agree and the people who disagree or strongly disagree. So I'm going to group these two things together and these two things together. You guys should already know how to do this from the last lesson. So I'm going to recode this into a different variable. Actually, you know what? Before I do that, let me check and see what the values are for agree and disagree. They're probably 1 and 2, but it makes sense to actually look. So I'm going to go here, men make better political leaders, and check. And yep, sure enough, it's a 1 and a 2 that I'll group together, and a 3 and a 4 I'll group together. Okay, so transform. I'm going to go a little faster because we just did this in the last lesson. It's not new so far. So men make better political leaders. I'm going to move that over. something really unoriginal. Sexism recoded. All right. Do you agree or disagree that men make better political leaders? Change. And you know what? Yes, agree. It was a 1 or a 2. Okay, so I'm going to plug in my old and new values. And in this case, I could do 1 equals 1, a 2 equals 1, a 3 equals 2, and a 4 equals 2. Or I could use my range again. In this case, a 1 through 2, answer is 1. And those were the people that agreed with that statement. A 3 through a 4 is equal to a 2. Those were the people that disagreed. I'm going to say all other values make system missing, add. That's going to be the people who said, I don't know, or answered anything else, okay? I'm going to click continue. Okay. Going to move that out of the way. And here is my newly created variable. And I just need to tell it, don't forget this important step, tell it that a 1 equals agree and a 2 equals disagree. Okay, don't forget that step. Okay, so I could go ahead and do a quick check on that one. I'm going to go to Analyze, Descriptive, Frequencies, get rid of that. Go down to my newly created variable, do men make better political leaders? And I'm doing this just to check to make sure that everybody is either a yes or a no. I'm sorry, they're either in agreement or a disagreement. And here is my thing, and yep, look, sure enough, I've got everybody is either in agree or a disagree. And again, that's the same number of people, my same n. These are the system missing people. So yep, all is good. That variable is now dichotomous. So now that that is dichotomous, I can be really sneaky and go ahead and check my significance, okay? So I'm going to Analyze, Descriptive, Crosstabs. Okay, Analyze, Descriptive, Crosstabs. I'm going to put, oops, get rid of this stuff. I am going to put, oops, let me close this so you guys can see it also. Sorry, the screen capture is not huge. Okay, so I'm going to put men or women. Let's put those in rows. And then I'm going to go down and put my new variable, do men or women make better political leaders, in columns. And then I'm going to tell SPSS, give me row and column percents. You guys, very, very important. Row and column percents. And then statistics. I want a chi-squared analysis at the end of this. Okay, so that was all. I clicked on cells. I said row and column percents. I clicked on statistics and I said chi-squared. So that's all I want. Then I'm going to click OK. And here is my answer. Let's see. So it looks like percent within sex gender. Who agreed? Okay, so this is the column of people who agreed with the statement, do men make better political leaders? All right. 476 people agreed with that. 206 of them were women. 270 of them were men. See where it says percent within sex gender? That says 53% of men agreed with that statement. 37% of women agreed with that statement. Okay? Make sure you need to stare at these tables until you realize how to read them, okay? So 53% of men, because percent within sex gender, that's the percent of men, percent within gender, men. So 53% of men agreed with that statement. only 37% of women agreed with that statement. So unsurprisingly, a higher percentage of men agreed with that statement than women, 53% to 37%. So is that a significant difference? Let's scroll down. Looks like my Pearson chi-squared asymptomatic two-sided is 0.000. So in other words, is that less than 0.05? Yep, you bet it is. And so the differences between how men and women responded to that question is significant. There is a significant difference in how they responded. Again, it's 53% of men responded that way, 37% of women responded that way. You guys don't have to write down 0.000. In fact, it's better if you don't. Just write p less than 0.05. If you want to look at this 2x2 table really quick, I see I have 3 minutes left. You can see that, okay, 53% of men agreed with that statement, 47% of men disagreed with that statement, and that was 100% of men. 37% of women agreed with that statement, 63% of women disagreed with that statement, and that was 100% of women, okay? This line, this number here, is the flip side of that. So that's percent within do you agree. So of the people who agreed with that statement in the sample, 57% were men, 43% of women, and that's 100% of the people who agreed with that statement. Okay? Hope that helps.